Hi, Stephen. How are you?
Hi, I'm good.
Hi, Harrison. How are you?
I'm good.
Hi, Kirsten. How are you? Hi, Kirsten. How are you? Hello? Hi, Kirsten. How are you?
Hi, I'm good.
Okay, okay. Let me send out a notice to Jiang. Any questions so far?
No,
Anyone really work on the musical problems? Hi, Harrison. Did you work on the musical problems?
Uh, yeah, but I didn't
Really?
work on that much this week though.
You didn't. That means you didn't.
I did.
How many problems you work on?
I did one though.
Which one?
I did.
Hello? How about Steven? Did you work on any problem?
No.
No, it's
Dr.
okay.
Chang.
Yeah?
I did the milking cows one.
Okay. How about Kingston? Did you work on any problem?
yeah, I was just working on some problem before I came.
Okay. My purpose is not finding problem with you, okay? Just make sure you move forward, okay? That's the whole purpose. If you don't want to compete, it's okay. I don't care, okay? I don't care. It's your own record. You get it or you don't get it, it's okay. But for me, I need to make sure you keep progressing, okay? Harrison know it. Is that okay?
Yeah.
That's the purpose, okay? My job is coaching, to coach you, not only to teach you. Teach you is to teach you the fundamental stuff, but coaching is making sure you exercise every day. You actually run the mile run you actually need to run, okay? How about Jiang? How are you?
I'm fine, thank you.
Did you work on any musical problems this week?
I worked on the 2026, the first contest questions.
Okay. Make sure, okay? If you have question, you're still welcome to show up in the 14 best sessions and we can discuss. Okay, anyway, let's get started. Today we are on the stacks. So right now we keep working on different kind of the standard libraries, the data structures. Okay, so one by one. Now we finished the array and the array list and the linked list. Now this one we will go into the so-called stack. Okay, some of the topic may be too hard. We may not go into it. Okay, this is too hard, but you can look at it. Okay. Okay. Anyway, first you need to know about stack is similar to array and linked list. Stack is also array based. So it's very similar to array list. In fact, stack can all be replaced by array list because your push pop can always add or remove from the tail. Okay, then it should be okay. Okay, and stack actually is also under the interface of list. So whatever function that list has, stack also has it. Okay, so these are the relationship that you need to know. So stack, the basic structure is that you need to know about the constructor, pick function, pop function, push function, and search function. These are the basic function you need to know. Let's get started to use it, okay? So there are not too many functions you need to remember. It's just push, pop, pick, 3 functions, okay? 3 major functions that you need to remember. Oh, this is Q, I'm sorry. Right here. The key point is the pick, push, pop, and pick. These 3 are the most important functions. And this is from java.util.stack. So when you actually want to use it, you have to include it, okay? Okay, so this one is where you need to get started to include a step from class. So you declare step of, let's say, integer. Okay, so you directly print out the step, it will be empty. So we also check the function of it's empty. At this moment, it actually is true, okay? And then step, just like array list, you can directly print out the contents. So right now it's actually empty. Now, that's because that you actually, this stack is also under the array list. So it also has the toString function by itself. Now with that, you actually start to push data into it there. And at this moment, we do these 2 functions again. Okay, so 1, 2, 3 was in the step, and then you check if it's empty. At this moment, if you do stem.out.print line, you run the function pick. Then it's 3. So what you need to remember is you have a stack like this. So we push 1, push 2, push 3. So 1 will go into there, and then 2 will go into there, 3 will go into there. So 1 is at the bottom, 2 is in the middle, 3 is at top. So when you pick, you look at the top of the stack. That's the current top level of the stack. Okay. That's the current level, top level of the stack. And then you will look at, you'll see a 3 over there. So now let's do this way. Let's do system pop. And let's pick again. So at this moment, you actually pop out the topmost element. So when you pick again, it becomes only 2 because you push in 1, you push in 2, you push in 3. Then you pop out the 3, so 3 got erased. And then when you do pick at that time, it actually got a 2. So keep doing that. you got a 1, okay? So you continue to do that, you will get a 1. So step, we say that it is first in, last out. It's a first in, last out data structure, okay? Okay, so this is the concept of the step. Let's actually print everything. Let's right here after the last pop out. Let's print the step status one more time. So it actually still has a 1 over there. Okay, and if you keep popping, so when you pop one more, there's nothing in the stack now, and you do pick. Then you got an exception because you are popping from a empty stack. Is okay?
Yeah.
Yeah.
So no more popping after your stack is empty. Don't pop anymore. Okay, so this is the concept of the step. Now next one, let's look at another thing that's called my step. If we want to build our own step, I don't want to use the Java step. What would be? So my step, let's actually use the integer types. Let's assume that we have an integer. Okay, here let's actually have a number called 20. 20 is actually the capacity. Okay. Capacity means how many data you can hold. So when you initialize a step, okay, you still also need to have a integer called top. Let's set it to be 0. So with this switching that we set up a array of 20 elements starting from 0 to 19. Okay, top is a pointer pointing to the index that you will fill the next data. So initially there's no data in the array. So the first data you want to fill is 0. So top equals 0 is okay. Okay, so right now, if you actually started with the array, you actually filling it, okay? Now, that's the constructor. Then we have 3 functions you need to check. So first one, let's actually implement a public integer size. Size means how many elements already in the stack. So let's assume that you push in 1, then your top go to here, it's actually become 1. And then you push in 2, then you top go to here, it become 2. You push in 3, you top to go to here, it's actually 3. So top is the next data to be filled in, the next index to be filled in. It is also the number of elements in the stack. So you can, if you want to check the current size, you can directly return top. That's the size of the step. Okay. So public integer Boolean is empty. You just check if top equals 0 or not. You will know about whether it's empty or not. Okay. Okay, this one. Okay, I multiply this pick function. So if you try to pick at this step, you have a 1, 2, 3, index 0, 1, 2. Top is actually right now at the 3. So when you pick, you want to find out the topmost data. The topmost data is located at the index top -1. Top don't have data. Top is the next location to be filled with data. Top -1 is where the last data is. So if your top go to 0, then you will have an empty step exception. But I don't want to raise the empty step exception, so I will return null. Is that okay? So this is multiplied. Not a standard way of doing it, but I prefer this one. Is that okay so far?
Yeah.
Okay, that's the pop pick function. This one, let's do push. So when you push data, you push a integer d into it, okay? Then you have to check your top and your capacity, okay? Because if your top is overflow, say you have only 19, but your top right now go to 20. The 20, index 20 don't have data. Okay, so let's do the simple case. So if actually top less than the capacity. Capacity is 20. If you are 19, you are still okay. But if you are more than 19, then it's not okay. Equals capacity is not okay. So you will do this, you will do okay. This one is the push function. Let's assume that you have 1, 2. Now you want to, your top is read 2. Okay, your top is 2. You want to fill a data 3 into there. Your top right now is 2. Index 0, 1, 2. You fill a 3, and then top increase to 3. So you do t plus plus. Any questions so far?
No.
So this one okay, and then we will return. Okay. So anything else, the capacity is greater or equal top. A top is greater or equal capacity. So you don't have enough data. Now you have to do you have to double your size of the array. Okay, you double it. And then you do this, you do for integer I equals 0, I less than data the length, I increase, you copy over. Okay, you copy over everything that was in the array. So let's assume that right now your capacity is 2. And you do have 1, 2, your capacity only 2. Your top is also at 2. So when you actually try to put the data into the index of 2, you will overflow. So at that time, you try to increase your capacity to become 4. But right now, your top still at 2. So you actually, right now, you can do the push function. Okay. And then you move you actually change the link of the data to data. So data get a new definition. It use a new array structure. Original one got abandoned. Is that okay so far?
Yeah.
Okay. This is push. Now let's look at pop. So pop, it is returning void, but we can actually modify it to return the data being pop up. Okay, we can modify it. The standard one don't have data that you can actually pop doesn't return data. So let's assume that you have 1, 2, 3. Top right now is over here. Top is actually 3. Now you want to take out the data of the 3. So your top need to go down to here to 2. But your 3 need to be take out. Okay. So we'll do this. We do integer data removed is R equals data's top minus 1. Okay, that data being removed. And then data's top minus 1, assign 0 to it. This one, you want to clean it or don't want to clean it, is okay. It doesn't matter. Okay. No, let's do the different way. Let's do this. Let's do top decreased. And then here we use the new top for it. Okay, this is either way to do it. then we will return R. But if top equals 0, you will have trouble, right? So if top equals 0, then you cannot pop out anything, we will return null. Okay? Any questions so far?
No.
To string, you don't need to do to string because this one, oh, actually you do. This is my step, it's not a standard library. So that's actually do to string. I use an angle bracket to make sure that it is different from the standard library. Okay, this is standard printer that we talk about it several times. So this is my stack. It's empty, pick, push, pop, and toString. I think this is everything needed. There's another function called search. Search is to return the position of specific element in the text stack. Okay, that's also implement. It's actually, you can just do the linear search. Because if you don't find the data, you return -1. Okay, this is linear search. Okay, so pretty much we implement everything that required by this. Okay, now let's actually create another one called use my stack. And then let's copy everything from use stack. Okay, and then step change to my stack. Okay, this integer, we don't have that t type. You can implement the t type, okay, if you like. Okay, anyway. Okay, is that okay so far?
Yeah.
So right here, there's one bug that actually it print out the whole thing. So the null bin print out. That's related to my print out function. So let me change it. Okay. So this one don't go to the length, go to the top. Okay. Because only up to top is the useful region. No. Oh, I'm sorry. I look at the wrong thing. It actually is this one. But actually the searching function also the same. Okay, sorry. Searching function also go to top only. Okay, I'm sorry. Okay. Okay. Any question? Now it's the same. So basically the function, the whole step we implemented with the same function that you can see. Any questions so far?
Nope.
Next one, okay. We have to step. Then Q is an interface. Okay, we don't talk about Q right now. Okay, we will talk about Q later. I don't want to actually confuse you. Okay, so stack is you can use draw the stack diagram to push in data, pop out data. Okay, like that. Okay, let's look at another thing now. Let's look at the use of stack. Okay, so we talked about a reversal array before. The reverse array you can do swap based, right? You can do reverse fill in way. Okay. Now you can also use a stack. So let's look at the reverse of array. Okay, I want to use stack. I don't want to use my stack. Okay, my stack is only to show you how it is built. So I'm using backup. Okay. Now I do have an array, so let's do integer array. Okay, so the initial data is 1, 2, 3, 4, 5. I want to reverse it. So I do this. Okay, so it got reversed. The idea is that you use a step to become a reverse of direction. So let's assume that you have a train. Your train is like this. You have 1, 2, 3, 4, 5. You have this stack. So you push in 1, 2, 3, 4, 5. And then it pop out from here. So your new array will be 5, 4, 3, 2, 1. So it's a reverse of direction, just like you drive a car, head into a parking space, and then you back up, and then you change direction then. Is that okay so far?
Yeah.
Yeah.
So this is use the step to do reverse of direction. Okay. Use the step to do the reverse of direction. Okay, this is one thing that commonly used is the reversal array. Okay, is to pick up data. Now let's do another things. Okay, let me try to find my program before. Actually, we talked about it before, the chess program. Maybe chapter 13 or 14. Let me see. Oh, I'm sorry. I'm trying to use the zip file. That's wrong. Now this one, not 12. Not a 12B. Not a 13. 13B, nothing. Not here. Let me go up to 10. No 10. Let me check the 18 then. Okay, I think this is what we want to have. This is tic-tac-toe game. Let's look at another one. Let's look at chapter 18. Not here. You see, it's not here. Okay, maybe in the second. Okay, let's maybe in here. Let's try look at the table. Okay, I think it's around this tic-tac-toe game. Right here. Okay, I'm going to copy this one over, okay? So let me actually copy all the whole thing. Okay. I'm going to look at it, put into the different directory. So this one is chapter 9. So I'm going to put a new directory. Let's call it chapter 9b. Put everything into here. Okay, so there's a chess game, okay? It's a chess game. Okay, so chess game, you draw the whole board. But we haven't played this chess game yet. Okay, now, the reason why I bring up this chess game is that now, you may move your stone. Okay, you may move your stone. Maybe you may pick up. That's a stone that you may want to pick up. You want to pick up, you go back. Okay, you may pick up. So this step can be used for each move. Move can go forward and then get back up. Okay. So let's create a new class called move. So this move is that you remember that where you get started, where you move to. Okay. And then when you move to, let's assume that here, right here, may have a white pawn over here. And you come over here, you may kill it. So you need to remember the stone that you kill. Okay, so you need to know about the stone that you killed. So when you create a move, I'm sorry, I put it wrong way. Okay, so this is your MOOC. Now you have the row number and column number. Let me see, okay, let me check. So 00 is R, 77 is capital R. So this one is 00, 00 means A1. 77 is H8, okay. This R right here is actually A8. Okay, so row is 1 to 8. Column is A to H. Okay. So it should be column of the front. To the colon of the front, and then actually row. Okay. Front and two. and the stone killed. Okay, these are the data you want to print now for the MOOC. So it should be A1 to B for kill a king, something like that. Okay. Okay, let's assume this is a MOOC class. Is used to represent a step that you do. Okay. Represent a step that you do. Now you want to do play chess. Okay, so play chess is another test chess function. But this time we will do play chess. Okay. So chess, this one right now, it has the creating the ball of chess, and then you do have the reset function. Okay. So chess itself is a ball. And ball have a array of M. Okay. Now, let's assume that we create a chess game C. Okay. Okay.
Hmm.
Okay. Is usually the turn to the white one. Okay, let me see. Let me check it. So white one is the lowercase, black one is the uppercase. Okay, it's okay. Okay, that is the wrong function. So we go into the wrong function, and when we go into the wrong function, first we will draw the ball once. Okay, is reset and then turn set to the white. So you show the ball first. So let's see, let's do this. I'm sorry. Okay. You show your ball. And you will get away for your comment. So this one would need to have the skin. Okay, so you get the scanner started there. And right here you say enter your move. So the move that we expecting would be A1 minus B4. Okay. This would be A1 minus B4. Okay, so if your input string is not 5 or not 1, then we will continue, we'll roll back. Okay. Clean the screen and redo. Okay, so we'll clean the screen. Otherwise, you look into it, okay? Okay, if you see a B, B means pick up. So right here, we'll do pick up here. Okay, and then we will return. We will, no, not return, we'll continue. We'll go to the clean up the screen and enter for the new move. Okay, so there will be a backup operation right here. Okay, no, actually this one, we don't need to do that. It will be continue, and then if it is not equal B, it will also continue. So we don't need to have an extra continue there. Okay, this one, if a B will do backup right here. If not a B, we'll go into here. Now, Okay, right here, actually, now 1, now 5, actually already continue. So right here, this if is not necessary, we don't need to check if the length is 5 or not. Actually, don't need to have that, okay? So we would have 5 character, it will be A1 to B4, okay? So let's look at the tic-tac-toe game. No, not this one. We need to look at the tic-tac-toe game. Okay, this whole portion will copy over, okay? Copy the whole thing over. So this one will be from colon to from row. Will be greater than H will continue, okay? That means it's illegal move. Okay, these are the from characters. Okay, and then we will need to work on the two as well. Character 3 and character 4 is 2. So we get this 2 column and 2 row. Okay. So we get a from column, from row, 2 column, 2 row. Now we need to check if there is a stone or kill or not. Okay. Then we go to the board. The board you can get from the row and column for the data. Okay. So if it's empty character, that means that there's no stone in there. Then let's see, we also need to have a character K. So no stone kill. Otherwise, you will kill a stone. Then your K will be equal to stone. Okay. So now let's assume that you actually have a P starting from here. You go to here. Okay, whatever. So the kill stone is this one got killed. So you assign this one got killed. Okay. So now you create a move. So this one is from row, from column to row to column and then stone killed. Okay, we remember the stone killed. Now, you will need to have a so right here you create a stack or move or moves. Okay. Let's assume that AB move is illegal. Okay, they may have the here you may need to check. Let's assume everything is legal. So it's a legal chess move. Okay, we only enter the legal chess move right now. Illegal, you have to check that. For example, you have a knight. You need to go to here, but if you a knight go here, it's illegal move. Okay, you only can go this way. So that's something that you need to check. Okay, but right now we assume we are just trying to give you the idea of the backup move. Okay, so we don't actually check whether the move is legal or not. Let's assume everything is legal. Okay, and then we want to we find out which move is going to be moved. Okay, now we want to we need to do two things. Let's assume this is knight over here and knight go to here. Here originally have a rook. Okay. Number one, this rook cannot be the same country. Okay, same side. Same side you cannot kill. Again, we don't actually check whether it's the same side or not. Same side we don't allow it to be killed. But right now, let's assume same side we also kill it. Okay, we also kill it. So what happens is that this one you will need to set to the knight. This one you need to clean. So front need to be clean. Two need to be set to the move, and then this one will go to the step, or you go to step. Something like that, okay? Okay, so first thing that's actually put to here. So your stone at the front being copied to the tool. Okay. So front row and the front column will be set to empty stone. Actually, it should be S. Okay, let me put this. No, I'm sorry. Let me check. We don't have S. I remember we have the S. Okay, S is underlined, so we need to use a chess.s. Okay, let's actually go to there. Okay, this empty stone is chess.s. So right here, I may need to change to chess.s. Okay, let's be consistent. Okay, next one, we are actually, it's legal, we killed it, and then we need to do moves that push what? Push your push what? Push a move into there, so your MB got pushed into there. Okay, up to here, okay? We will check backup later. Let's go up to here to see if the stone is okay. Right here, let's use a counter. So every time you counter, no, let's use a different later. Okay, we allow 10 steps right now. Okay, let's do 5 only, okay? 5. Then we will do down equals 2. Okay, this one is related to check if the game is over or not, okay? But right now, let's use a counter because we are not ready to check the game situation yet. Okay, so only 5 move. Let's try. No. Let's create a new class. Okay. Let's see. No pointer exception. Oh, C not created. Okay, enter your move. Let's enter. Okay. So let's do A2 to A4. Is that okay? No? Is that okay now? Okay. So I do A2 to A4, it go to here. Okay. Let's try another move. Let's do G7 to G5. Okay. Right now, let's try something illegal. Let's do 7-7, 7-7-8. Okay, it won't do anything. 7-7 to 7-7, it won't do anything. Okay, so this one well protected. So now the move forward part is okay. Now let's look at the backup. So your move may be back. So 5 move, let's finish 5 move. Okay, 5 move is not a lot. Okay, so it's done. We're not done already. Okay, I just, oh, one more. Let's do G5 to G4. Still queen. How comes? Let me stop it. I only allow 5 move. Counter plus plus. Oh, here it should be down equal to. I'm sorry. Okay, now let's look at the backup. Backup portion is that you actually, when you see a single comment that's actually B or B, that means backup. So you pick up right here. So you pick up, you actually would have a move, pop up move, PP, PR, okay, PV, okay, PV, pop up move, okay, pop up move. You pop a move, and then you need to get an integer. Let's go back to move, okay, move with the from row from column to row to column. Let's actually copy these things over, okay. Okay, so this one, you from the move, you pop up a move. You get the data of the row column. If it is encapsulated, you have to use a get function. Okay, right here, I'm trying to just be easy. I don't use the private data, okay? So R1, C1 is the front row, front column. C1, R2, C2 is the 2-row, 2-column. And then KK is the stone killed. Okay, now you get these different data, you need to restore the data. So let's assume that this move, actually, let's go back to here. You go here, you actually move to here. Okay, and then you kill the stone P, so P got pushed to the data. So you go to here, right? And then you kill P. You kill P when you want to pick up. You want to pick up then your data first. You put the data original in 2 location. In the 2 location to the front location. Okay, so put a P over here. I'm sorry. This one you need to, so this one should be N, okay, it should be N. You put the data in the 2 location to the front location. Okay. This one you put the key or stone back to the 2 location. Okay, these are two things that you need to do. Let's do it. Okay. Then I will go back one step. You actually, so this, what I want to say is that stack is used to back up. The first one is to do reverse. This one to do backup. Okay, backup operation. If you back up, so when you back up, you must remember what data need to be used. Okay, let's try this backup function now. Still 5 step. Okay, still 5 step. Counter still count to 5. Okay. Okay, let's still count to 5. Let's do it. Okay, let's try this. Let's try A2 to A4. Okay, now I'm going to do something illegal, but you will check if the backup is correct or not. Okay, so I'm going to call this one to here. Okay, so let's do A7 to A4. I just check if it work. Okay, now let me do one more. One more is that this R will kill it as well. Okay, so let's do A1 to A4. Okay, now I kill 2 stones, so I want to do backup. So let's do B. Let's do B again. Okay. Let's do B again. Okay. Any questions so far? Now, let's go back. One more thing need to be done. So here, backup, you check the B. One more thing you need to check is if moves that is empty, then you don't need to pick up. Okay, if your move, you don't have any move inside the step, then you cannot do any pickup. Is that okay so far?
Yeah.
Okay.
Yep.
So what I want to say is that I will give you this example of playing chess, just because that chess is a game that you will have the move, you will have the kill of the stone, okay? And then you will know about the pickup, what to do the pickup, okay? But in terms of the pickup, sometimes you may do recursion. So you come here to here to here to here. Sometimes you do recursion, you go to here, but you want to pick up. Then the status of the node need to be back up to the status on this node. So it's happened very often in recursion. Okay, we'll talk about it later. Okay, we'll talk about the recursion and the step later. Right now, we don't work on that step and recursion. That's too much. Okay, but here today we actually introduced two concepts. Number one, step is used for reverse of the array or some queue. Okay, next one is also used for backup the steps. Okay, and the backup the steps, we use the chess game as an example. Okay, now you can change the counter to be bigger, or if you have time, you can actually go to what? Implement the game over condition to check if the king got killed and declare the winner. Okay? But this win condition is very easy to detect, right? Win condition very good. So if you are K missing, then mean this is white. White don't have king, then black win, right? Is that okay? Big K missing, then white win. Okay? That make sense?
Yeah.
The game condition is not difficult to check. It's easier than the tic-tac-toe game. Okay? You can just use if there is a king in the white king and black king in the chessboard. You will know it. Okay, but I don't want to implement. It's too easy. Okay, this version up to here, I don't want to. It's already quite long already, right? This program is already quite long. But so you can see, step is very powerful. It can be used to remember the status of your program. Okay. Now let's go back to the slices. Let's talk about queue, and we are going to wrap up today. Okay. There are more material that we cannot cover today that I talk about. Is the evaluation tree problem. Okay, that's too much. That would take a whole day to finish, but we don't have that kind of time right now. Okay, we'll save it in the data structure course to discuss it. Now let's look at Q. Q is different from a step. Q is an interface. So because it's an interface, so you actually cannot create an object called Q. It's impossible to create an object called Q. So you either create a priority queue or array DQ. Okay, you either create a priority queue or DQ. Priority queue would have the queue, but with the priority, so we don't like it. Normal queue, if you cannot use a normal queue, you can use an array list to replace queue. Okay, you can use array list to replace queue. But array list is not under Q, so you cannot use a Q equals array list. That actually is wrong. Okay. But you can use a array list to mimic the function of a queue. But if you use a priority queue, that is not a queue. It's a priority queue. It comes with priority. Okay. If you declare a DQ, double-ended queue, that's too much. That's a different data structure. Okay. Okay, so here we just talk about the basic function of the queue. We are not going to do too much about queue right here. Queue is too simple. Okay. But later we'll talk about array DQ and priority queue. Okay, we'll talk about it. Let's go to queue. So queue has pull, remove, pick, and element. Over, okay, there's a function called over. So over is to put the data into the queue. Pull is to retrieve and remove the head of the queue and the null if the. So this one is pull. Remove is the remove and head of this queue. I'm sorry, actually pull and. Okay, remove is taking data from here. From the tail, okay? You say head, but it's actually its tail. So pull would return null if it's actually no data in the queue. While move will throw an exception. So pull is better. Okay, pull is better. Pick is look at the head of the data, but not remove. So pick just look at the data over here. And then next one is element. So element is the throwing exception version of the pick. So usually use a pull and the pick is better. Okay. And remove is a version of the pull. Exception version of the pull. Element is exception per version of the pick. That's it. Q is pretty simple. In a way, it's only used as a buffer. Okay. It's only used as a buffer. Let me go back to the previous one. Okay, I go back to the chapter 9. I don't want to use chapter 9b. I want to go to the chapter 9. 9b is for this chess game only. Okay. Let's go to the chapter 9. Okay, so right here, let's create another one called user queue. Okay, so this one pretty easy. You have a data of 1, 2, 3. You actually move into the data, so you actually take one, put into the queue, you'll be 1, 2, 3. When you pull it, you get out 1, 2, 3 in order. So usually queue is only used as a buffer. So the data first in, first out. Okay. Now there's your question. For Kingston, why we need to have the first in, first out buffer?
Why do you need a first in, first out buffer?
Yeah. When we were using.
I have no idea.
How about Jiang? When we will use a first in, first out buffer?
When you're printing out something,
Yes, print out something, yes. Other situation?
or like making like a queue system.
Why you need to have a queue system? We say queue is the first in, first out, but why you need to have a queue system? Where
Because
you will use it?
when there are multiple threads or like, yeah.
Multiple thread is not necessary. You don't need to be multiple threading. Single thread, okay. Multiple thread is one example, but not necessary. How about Harrison? When do you need to have a data that got buffered?
Like having to implement like redo and undo.
No, that's not related to here.
I'm not sure.
Okay, so ideally, if you look at the algorithm basis, the data first in, first out actually not doing anything. It doesn't transform any data. It doesn't change the data. It doesn't reverse the relation. It doesn't do anything onto the data. But FIFO or buffer is very widely used, very, 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 very useful. Okay, it is very, very useful. Number one, streaming. You download things from YouTube. There is a communication channel, there's an internet, right? So you download some video to your local, but the channel is very dirty. So sometimes you get some package, sometimes you don't. So if you play the YouTube without buffer, then you cut a package and you play, and the next one may go 3 minutes before it comes. Then your video got stopped. So a better way is that let's actually do buffer 1,000 packages first. And then so I have a 1,000 packages. So every 5 seconds I play one package. Every 1 second I play one package. Keep consuming it. And my package I keep arriving. So the package may go 2 seconds, one package is 5 seconds, one package, 10 seconds come in another package. So it's the time of arrival is not very stable. But your playback can be very stable. So usually the buffering is to remove the latency problem, making things consistent. Is that okay?
Yeah.
Xiang, is that okay?
Yeah.
Another thing is reordering. So what Jiang say, the multi-threading environment. Everybody create a package. And then, so these are producer. You have multiple producer to produce data. They're the only one consumer. But each of the data may have a time stamp. So you may receive this one, that's number 2. and this one number 7, and then number 4. So they are out of order. They are out of order, so I actually, if I put them into a priority queue, lower order go first out. Then even though 4 is arriving later, but 4 will be used before 7. Then this one providing a reordering feature. Does that make sense? So one is to buffer. Second one will provide the reordering. So buffer or queue is widely used in operation system or networking. A lot of situation, system software will use a queue. Okay? Or your memory cache, trying to get the memory data from your main memory. But your CPU is consuming some data. You want to keep the CPU working. So there's a caching over there. Okay, internet also has a cache. Okay, is that okay so far?
Yeah.
Hello? The
Yes.
functionality is very easy, but you need to know when to use it, okay? So today we are up to here, okay? Good night then, bye-bye.
Bye. Thank you.
Bye-bye.
Thanks.
Thank you. Bye.